Hello everyone, welcome to my channel. In this video, we will learn about the dijkstras algorithm. So dijkstras single source shortest path algorithm. So we are going to solve this algorithm using the greedy method. So in the case of the dijkstras algorithm, we will find the shortest path from a single source to all other nodes in a graph with the non-negative edge weights. Okay, so here we are going to find out the shortest path from a single source to the destination to all other nodes in the graph. So we are finding the path from single source to all other nodes in a graph. So which is the shortest path to travel from the source to the multiple number of nodes in the graph. So for this, so we are following the algorithm here. Set distances for all nodes, that is source will be initially 0 and the other nodes, so other nodes distance will be infinity, since we have not found the distance from the source to the remaining nodes, so it will be infinity starting at the start. And create empty shortest path reset. So next, main loop. So while there are unvisited nodes, find unvisited node with the minimum distance, add it to the shortest path tree. And for each neighbor of current node, update its distance if going through current node is shorter. Okay, so we need to, so we are going to find the shortest, the less cost node, and we are going to find the distance from the minimum cost node to the remaining nodes. Okay, so when all the nodes are in the shortest path tree, distances hold the shortest path from source. So this is the example of the how do we solve the dijkstras algorithm. So here from the single source, so we will search how to reach the remaining nodes here with the less cost. So now let us see the example of the dijkstras algorithm. So here given the graph, so 1 to with the nodes 1 to 7. So here 1 is the starting point, and the single source shortest path algorithm, so we have to find out the best solution to reach the remaining nodes. So what is the shortest path to reach the remaining nodes? Okay, from the source to the remaining nodes. So this given the graph. So here the node 1 is connected with only 2 and 6. The cost of the node 1 is 1 to 6 is 30 and 1 to 2 is 10. And for the remaining nodes we don't know the cost. So we need to find out the cost using the shortest path, dijkstras algorithm. We need to find out the cost. So initially the source will be 0 and the nodes which are not reachable directly from the source node is made as infinity. So now selected vertex is 1 and the visited vertices are 1 only. So d 1 to 2, that is d of 2 is 20. So the cost of 2 is 20 here, and 3 is infinity because we cannot directly reach from the 1 to 3. So that is infinity, 4 is infinity, 5 is infinity, and cost of 6 from 1 is 30 and 7 is infinity. So now we need to find out the, so from the unvisited nodes, so these are all the unvisited nodes. Okay, from unvisited nodes we need to select one of the minimum distance. Okay, from the unvisited node we need to find the minimum distance and add it to the shortest path tree. So we have to add it to the visited vertices. Okay, so what is the minimum node here from the unvisited? 20. So 20 is the minimum node. So we need to select this vertex here. So selected vertex is 2 and visited vertices are 1, 2. Okay, so 1, 2. So now, so what are the neighboring nodes of 2? So 2 is having the neighboring node 3, only 3. It is directly connected to the 3. So the cost of 2 to 3 is 20. Okay, so now what is the cost of 2 here? So 2 is So here the d of, sorry, so 1 to 2 is 10. So 1 to 2 is 10. Okay. So 1 comma 2. So here 2 to 3 is 20. So already the cost of 2 is 10, and so we have to reach the 3. So 1 to 3. So through the 2. So that is 10 plus 20 is 30. So 10, and d of 3 cost is 30. So remaining or infinity. Okay. So now, so we will find out the shortest of the remaining nodes, the unvisited nodes. So here 2 is visited already. So these are the remaining unvisited nodes. So here 30. So both are equal. Since 3 is the first node, 3, the node 3 will come before, right? So that's why we are considering the node 3 here, even though they are having same weights. So node 3 is selected. Now selected vertex is 3 and visited vertices are 1, 2, 3. Okay. So now we will write the values here as this. So d of 2 is 10, d of 3 is 30. So what are the neighboring nodes of 3 here? So 3 to 4 and 5. So 3 is connected to 4 and 5. So how do we reach from 1 to 4? So 1, 2, 3, 4. So we need to calculate all these values here to reach the node 4. Okay, 10 plus 20, that is 30, and 30 plus 15, that is 45. So in order to reach from the single source 1 to 4 is the cost is 1 to 4, the cost is 45. So 45 is the cost. So next, what is the neighboring node of 3? 5. So in order to travel from 1 to 5, so how do we travel? So 1, 2, 3, 5. So 10 plus 20 plus 5, that is 35. Okay. So from the from the nodes here, so what is the minimum cost? So 30, that is a 6, node 6 is having minimum cost. So now next let us visit the node 6 here. So node 6, 1 comma 2 comma 3 comma 6. So 10 is a visited node, 30 is visited, and 45, 35, and 30 is visited node, right? So what is the direct node from 6 to 7? So the node connected to 6 is 7 only, right? So that is 35. 6 to 7, 35. Okay. So 35. So in order to reach from the travel from source to the node 7, what is the cost? So 30 plus 35. Okay, so it was previously infinity, so now we will change it to 65. So here we are changing the infinity to 65. So next, so among the given nodes, what is the node with less amount of cost? So 35, right? So next we will visit the node 5. 1, 2, 3, 6 and 5. Okay, so 10 is visited, 30 is visited. So now, so what are the neighboring nodes of the 5? So the neighboring nodes of 5 is only 7, right? So neighboring node is 7. So 45, 35, 30 and 7. So how do we reach from 1 to 7? Okay, how do we reach from, travel from 1 to 7? So we need to traverse through all the nodes. So 1 to 2, so 1 to 2, 2 to 3, 3 to 5 and 5 to 7. So that is 10 plus 20, 30, 35 plus 7, that is 42. So the value will get changed to 42 here. So now among the given nodes here, which is smaller one? So node 7 is smaller. So we will select the minimum cost here. So now node 7. So visited vertices are 1, 2, 3, 6, 5 and 7. So now write down this as it is: 10, 30, 45, 35, 30 and 42. So now what is the remaining node, unvisited node here? 4. So now we will visit this node also, 4. So 1, 2, 3, 6, 5, 7 and 4. So 10, 30, 45, 35, 30 and 42. So now all nodes are visited here. Okay. So this is how the Dijkstras algorithm is working. So now we will find out how can we travel from the node 1 to node 7, and what is the minimum in how much minimum cost we can travel from node 1 to node 7. Okay. So here the cost. So 2, 3, 4, 5, 6 and 7. So the cost of 2 is 10, 3 is 30, 4 is 45 and 5 is 35, 6, 30 and 7 is 42. So this much cost it will cost for to travel from the node 1 to the remaining nodes. So this is about the Dijkstras single source shortest path algorithm. Thanks for watching the video.